Hello guys, this is research series, and in this session I want to teach you how to perform logistic regression. And what is logistic regression? Logistic regression is used when you want to measure the effect of one or more than one variables on a qualitative variable which has two moods. For example, in this study I want to measure the effect of age, sex, and for example smoking status or BMI on stress grouping. My stress grouping includes just two moods, having stress or not having stress, so I can use logistic regression. Logistic regression can calculate the OR or odds ratio for this study. In order to perform the logistic regression, you can choose analyze, and then you have two options, one of which is regression and the other one generalized linear models. In this session I want to teach you the regression and then binary logistic regression. As you can see here, I have inserted stress grouping in the dependent list. You can just select it and use this icon here to send it here, and I have sent age, sex, and physical activity and marital status in the independent variable list. And you have some options here, for example categorical, and you can use this option when you want to measure the effect of one of the categorical for example variables, and you then want to measure the effect of different subgroups of the categorical covariate or categorical variable. For example, you can send physical activity here, and then you need a reference category. Reference category means that the group you want to compare it with other groups, and it is like a control group, and other groups are just compared with this one. But in this study I just want to measure the effect of scores in each one of these variables on the outcome. If, for example, I detect a positive OR for sex, then it means that the group male or female having or determining to have a higher number is suggested to predispose patients to higher risk of stress, and I don't want to measure the differences between subgroups, so I can just leave it with continue. And you have also this icon options. Please be sure that you have chosen this icon to include confidence interval in your study, and then click OK. As you can see in this table, I can see in this column that just age has a significant p-value for having or not having stress, and as the OR odds ratio, this column exponential beta or exponential b value is the odds ratio. This column shows that age is negatively associated with the presence of stress, so I can conclude that stress is less likely in older age, but the other variables were not significantly associated with the presence of stress. For example, as you can see here, these numbers, the distance between, for example, 3600 to 1.1 includes 1 if the distance between the lower bound to the upper bound includes 1, then you can conclude that the variable is not significantly associated with the outcome. But for age, you can see that the distance between the lower bound to the upper bound does not include 1, so it is significantly associated with the outcome. If your odds ratio is less than 1, then it is negatively associated with the outcome, and if it is more than 1, then it is positively associated with the outcome. For example, in this case, I can tell you that having an older age is decreasing the risk of stress by 10%. If you enjoyed this video, please don't forget like, subscribe and comments. See you soon.